Here is a numerical type question. Work through the numbers carefully. Let us solve it step by step. Let us first understand the key concept here. Compounds that react with Na metal to evolve H2 gas must contain an active hydrogen bonded to an electronegative atom, OH group. For C4H10O, the functional groups possible are alcohols, RO, and ethers, ROR. Only alcohols react with Na to release H2, ethers do not. Moving on to the next step. Determine the degree of unsaturation for C4H10O. Degree of unsaturation is equal to 2 times 4 plus 2 to 10, 2 is equal to 0. So no rings or double bonds, the compound is saturated. Moving on to the next step. List all alcohol isomers of C4H10O, structures with OH group, excluding stereoisomers. 1,1-butanol, CH3CH2CH2CH2O, N-butyl alcohol. 2,2-butanol, CH3CH2CH, OH CH3, set-butyl alcohol. 3,2-methyl-1-propanol, CH3, 2CHCH2O, isobutyl alcohol. 4,2-methyl-2-propanol, CH3, 3COH, tert-butyl alcohol. And for the final step, list all ether isomers of C4H10O, structures with ROR linkage. 1-diethyl ether, CH3CH2OCH2CH3. 2-methylpropyl ether, CH3OCH2CH2CH3. 3-methyl isopropyl ether, CH3OCH, CH3, 2. These three ethers do not react with Na to give H2. Count only the alcohols, since only they react with Na to evolve H2. There are exactly 4 alcohol isomers of C4H10O. Why ethers fail? Ethers have no OH bond, so they cannot donate a proton to Na and do not produce H2. Therefore, the correct answer is 4. Therefore, the correct answer is 4.